Let's continue, children, with Geography, Unit 3, Hydrologic Cycle. Children, in this session, you will be learning about the components of hydrologic cycle. Okay, let's get started. Children, there are 6 main components in hydrologic cycle. They are evapotranspiration, condensation, precipitation, infiltration, percolation and runoff. So the 6 main components in hydrologic cycle are evapotranspiration, condensation, precipitation, infiltration, percolation and runoff. Is it clear, children? Now let's learn about them one by one in detail. Children, the first component is evapotranspiration. Children, evapotranspiration is the combination of both evaporation and transpiration. Children, due to the heat of the sun, evaporation takes place on the surface water, that is on the oceans, seas and other water bodies. And transpiration takes place through the leaves of the plants. Hence, there is a loss of water during this process. Is it clear, children? So, children, we can define evapotranspiration like this. It is the total loss of water from the earth through evaporation from the surface water bodies and the transpiration from vegetation. Children, in cropped area, it is very difficult to determine the evaporation and transpiration separately. Therefore, it is collectively called as evapotranspiration. So, once again, I repeat, evapotranspiration can be defined as the total loss of water from the earth through evaporation from the surface water bodies and the transpiration from vegetation. Is it clear, children? Now, let's understand the concept of evaporation clearly. Children, evaporation refers to the process in which the liquid form of water changes into gaseous form due to temperature. So, what happens during an evaporation process? Yes, the liquid form of water changes into the gaseous form due to temperature. So, children, temperature is the prime element which affects the rate of evaporation. So, there is a positive relationship between these two variables, that is evaporation and temperature. If temperature increases, there is more evaporation. If temperature decreases, there is less evaporation. So, they are proportional to each other. Is it clear, children? Children, evaporation is one of the main steps in a water cycle. Children, normally water boils at 100 degrees Celsius or 212 degrees Fahrenheit at sea level. But it actually begins to evaporate at 0 degrees Celsius itself. So, children, because of the heat of the sun, evaporation takes place on the surface water. So, as I already told you, temperature is the prime element which affects the rate of evaporation. And this process takes place very slowly. Is it clear, children? Children, the other variables which affect the rate of evaporation are, first, areal extent of surface water. Children, areal extent of surface water is an important factor which affects the rate of evaporation. So, if the surface water is more, the rate of evaporation is more. And if the surface water is less, the rate of evaporation is less. So, they are proportional to each other. Is it clear? The next variable which affects the rate of evaporation is wind. Children, increase in the wind speed results in increased evaporation, and decrease in the wind speed results in decreased evaporation. So wind speed and rate of evaporation are proportional to each other. Is it clear? The next variable is atmospheric humidity. Now what is humidity? Humidity is the moisture content in the air. Children, the rate of evaporation decreases with an increase in humidity and vice versa. So, humidity and the rate of evaporation are inversely proportional to each other. So, children, the variables which affect the rate of evaporation are temperature, areal extent of surface water, wind, and atmospheric humidity. Is it clear, children? So, children, to conclude, we can say that the rate of evaporation increases with increase in wind speed. Next, increase in temperature. Then, decrease in humidity. And increase in areal extent of surface water bodies. So, children, evaporation is one main component in the water cycle. Is it clear, children? See, children, the atmosphere gets nearly 90% of its moisture from the oceans, seas, lakes, and rivers through evaporation. And the atmosphere gets 10% of the moisture from plants through transpiration. So, the atmosphere gets nearly 90% of the moisture from oceans, seas, lakes, and rivers through evaporation, and only 10% of the moisture from plants through transpiration. See, children, on a global scale, the amount of water that gets evaporated is about the same as the amount of water delivered to earth as precipitation. Children, precipitation can take the form of rain, snow, freezing rain, sleet, etc. But this process varies geographically. Children, over the oceans, evaporation is more than precipitation, and over the land, precipitation exceeds evaporation. So, children, evaporation is the first step or the first component in a water cycle. So far, did you understand, children? Good. Next, let's learn about transpiration. Now, what is transpiration? Yes, transpiration refers to the process by which the water content in the plants are released into the atmosphere in the form of water vapor. See, children, much of the water taken up by the plants is released through transpiration. Children, actually, plants absorb water through their roots. 99.5% of this water is not used by the plants for their growth. It is actually the excess water. And this excess water is released into the atmosphere through the leaves of the plants in the form of water vapor. This process is called as transpiration. So again, I repeat, transpiration refers to the process by which the water content in the plants are released into the atmosphere in the form of water vapor. Is it clear, children? Children, transpiration is not always the same. Several factors affect transpiration. The first one is temperature. Children, when temperature is high, the rate of transpiration increases because the stomata on the leaves, which is responsible for transpiration, opens even in the darkness. So, temperature is one factor which affects the rate of transpiration. Is it clear? The next factor which affects transpiration is wind. If the wind speed increases, transpiration also increases. And if the wind speed decreases, transpiration also decreases. Because when the speed of wind is more, the saturated air around the leaves is removed, which allows it to transpire. Is it clear, children? The next factor which affects transpiration is humidity. If the humidity is more, transpiration is less because the water content in the atmosphere is more. And if humidity is less, transpiration is more because the air is dry. So, humidity and rate of transpiration are inversely proportional. Is it clear, children? The next factor which affects the rate of transpiration is nature of vegetation. Children, if the surface area of the vegetation is large, then there is more transpiration. And if the surface area is less, then there is less transpiration. So, transpiration and nature of vegetation are proportional to each other. So, children, the rate of transpiration depends on temperature, wind, humidity, and nature of vegetation. Is it clear, children? Children, did you understand about transpiration clearly? So, children, evaporation and transpiration are the key elements in a water cycle. Is it clear, children? Now, let's learn about condensation. Children, condensation is the second component of the hydrologic cycle or water cycle. Now, what is condensation? Yes, condensation is the process where water vapor becomes liquid. We can also say like this. It refers to the process in which the gaseous form of water changes into the liquid form. Is it clear, children? Now, when does condensation takes place in the air? Yes, condensation generally occurs in the atmosphere when warm air rises, cools, and loses its capacity to hold water vapor. As a result, excess water vapor condenses to form cloud droplets. Is it clear? So, children, condensation is responsible for the formation of clouds. Now, these clouds produce precipitation in the form of rain, snow, freezing rain, sleet, etc., which is the primary route for water to return to the earth's surface in the water cycle. So, children, condensation is the opposite of evaporation. See, children, condensation can take different forms. They can be in the form of dew, frost, fog, mist, and clouds. Now, let's learn about them one by one. The first form of condensation is dew. Have you ever seen dew, children? Yes, you might have seen them in the morning on the leaves and other things outside your house in the form of small water droplets. You can also see them in the clipping here. So, children, dew is a water droplet. And how is it formed? Yes, it is formed by condensation of water vapor in the night. Children, it is formed when the temperature of an object drops below the dew point temperature. Now, what is dew point temperature? Yes, dew point temperature is the temperature at which the atmosphere is saturated with water vapor when it is cool without changing its pressure or water content. So, children, dew is a water droplet formed by the condensation of water vapor on a relatively cold surface of an object. Is it clear, children? The next form of condensation is frost. Have a look at this clipping, children. Can you see ice crystals there? Yes. So what is frost? Yes, frost is ice crystals formed by the deposition of water vapor on a relatively cold surface of an object. Now, when is it formed? Yes, it is formed when the temperature of an object drops below the freezing point of temperature. Now, what is the freezing point of temperature? 0 degrees Celsius is the freezing point of temperature. So, again, I repeat, frost are the ice crystals formed by deposition of water vapor on a relatively cold surface of an object. It forms when the temperature of an object drops below the freezing point of temperature. Is it clear, children? The next form of condensation is fog. Have you seen fog, children? Yes, you might have seen them in the early mornings, especially when you travel. You would have felt as though a dense layer of cloud is in front of you, isn't it? So what is fog? Yes, fog is the suspended tiny water droplets or ice crystals in an air layer next to the Earth's surface that reduces the visibility to 1000 meters or lower. See, children, for aviation purposes, that is for air travel, the criterion for fog is 10 kilometers or less because foggy weather makes it difficult for the pilot to fly the plane. So, fog is the suspended tiny water droplets or ice crystals in an air layer next to the Earth's surface that reduces the visibility to 1000 meters or lower. Is it clear, children? The next form of condensation is mist. Just take a look at this clipping, children. Mist is somewhat similar to fog, isn't it? But there are some differences between fog and mist. They are both created by water droplets. The only difference is in their location and density. See, children, fog is a cloud that reaches the ground level even if that ground level is a hill or a mountain top, whereas mist forms wherever water droplets are suspended in the air by temperature inversion, volcanic activity, or changes in humidity. So we can explain mist like this. Mist is the tiny droplets of water hanging in the air. These droplets form when the water vapor in the air is rapidly cooled, causing it to change from invisible gas to tiny visible water droplets. And children, mist is less dense than fog. Moreover, fog lasts for a longer period, whereas mist lasts for a short time. So mist is the tiny droplets of water hanging in the air. These droplets form when the water vapor in the air is rapidly cooled, causing it to change from invisible gas to tiny visible water droplets. Is it clear, children? The next form of condensation is clouds. Children, when we look up at the sky, we see clouds of different shapes and sizes, isn't it? Now, what are these clouds made of? Yes, they are made up of water drops or ice crystals which keep floating in the sky, as you see in this clipping here. So, children, clouds consist of tiny water droplets or ice particles which are so small and light in weight. To say more accurately, they are microscopic drops of water, which means they are very, very small, and small ice crystals. See, children, the size of the droplets generally range from a couple of microns to 100 microns. Now, what are microns? Microns are a unit of length equal to 1/1,000,000th of a meter. So now you will be able to imagine how small each water droplet would be. And now, when the size of the water droplet exceeds 100 microns, it becomes raindrops. That is, precipitation starts at this point. So, children, clouds consist of tiny water droplets or ice particles which are so small and light in weight. Is it clear, children? So, to conclude, we can say that condensation occurs when the air gets saturated, that is, when the air absorbs a maximum quantity of water. Then, warm air can hold more water vapor than the cool air. Then, saturation occurs when the temperature drops down. So, children, condensation is the second main component in the hydrologic cycle or water cycle. So far, did you understand, children? Good. Now, let's learn about precipitation, which is the next component of the hydrologic cycle. So, what is precipitation? See, children, precipitation refers to all forms of water that fall from clouds and reaches the earth's surface. Here I say all forms of water because precipitation is any liquid or frozen water that forms in the atmosphere, and it comes in many forms like rain, sleet, snow, etc. Children, along with evaporation and condensation, precipitation is one of the three major parts of the water cycle. So precipitation refers to all forms of water that fall from clouds and reaches the earth's surface. Is it clear, children? Children, for the occurrence of precipitation, that is for precipitation to take place, the cloud droplets or ice crystals must grow heavy enough to fall through the air. So, when the droplets grow large in size, they tend to fall down back to the earth in the form of rain, snow, sleet, etc. See children, the atmosphere is mixed with particles of dust and smoke. Now these particles are called as condensation nuclei. This condensation nuclei provide a surface for the water vapor to condense upon. This helps the water droplets gather together and become large enough to fall to the earth. So the cloud droplets or ice crystals must grow heavy enough for precipitation to take place. Is it clear, children? Children, there are different forms of precipitation. They are rain, sleet, freezing rain, hail and snow. But children, one important thing here is that each form of precipitation in a region depends on the kind of weather or climate of that region. See children, if the weather or climate of that region is warmer, the precipitation is in the form of rain or drizzle. And if the weather or climate of that region is colder, the precipitation is in the form of snow or ice. Is it clear, children? Okay, now let's see the different forms of precipitation one by one. The first one is rain. Children, do you like rain? Yes, most of us like rain because it gives a cool feeling. Okay, now let's understand about rain a little more. Children, rain is the most common kind of precipitation. Now what is rain? Yes, rain is the precipitation in the form of water droplets. So rain is the precipitation in the form of water droplets. Is it clear, children? See children, if the size of raindrops is less than 0.5 millimeters in diameter, it is known as drizzle. And if the raindrops is more than 0.5 millimeters in diameter, it is known as rain. Is it clear? Okay. Now, generally, drizzle takes place from stratus clouds. Children, actually, the stratus clouds are low-level clouds that are flat and featureless, which are capable of producing slight drizzles. So children, rain is the precipitation in the form of water droplets. So children, did you understand about rain? Good. The next form of precipitation is sleet. Children, have you heard about or seen sleet? In Tamil, we call it as kalmazhai. Okay, now let's learn some more about sleet. So what is sleet? Children, sleet is a form of precipitation which takes place in the form of mixture of water droplets and tiny particles of ice which is 5 millimeters in diameter. So a mixture of water droplets in the form of rain and tiny ice particles which is almost 5 millimeters in diameter is called as sleet. Is it clear, children? Now, let's see how sleet is formed. See children, sleet falls when the temperature is cold. Sleet actually begins with the snowflakes in the atmosphere. As the snowflakes fall towards the ground, they pass a warm layer of air. So the snowflakes melt and form raindrops. So now what happens is that the raindrops move towards cold surface temperature. That is, they pass through a thin layer of air whose temperature is below 0 degrees Celsius, which is the freezing point of water. So naturally, what happens here? The raindrops refreeze into pellets of ice and fall to the ground as mixture of raindrops and ice. This is called as sleet. So children, sleet is a mixture of water droplets and tiny ice particles which is 5 millimeters in diameter. So children, did you understand what is sleet? Good. The next form of precipitation is freezing rain. See children, sometimes raindrops on their journey from clouds to the ground, that is on their journey through the cold air, do not freeze in the air. They actually get super cold but do not freeze while remaining in the air. They remain in the liquid form. But when they touch a cold surface, they freeze. This is called as freezing rain. In Tamil, we call it as Urai Pani Malai. Children, the freezing rain drops usually are greater than 0.5 millimeters in diameter. So children, raindrops which freeze on touching a cold surface is called as freezing rain. So children, did you understand about freezing rain? Good. The next form of precipitation is hail. Children, in Tamil, we call it as Alangatti Malai. You might have also seen it, isn't it? Okay, now let's know some more about hail. So what is hail? See children, hail is a form of solid precipitation. It consists of round pellets of ice which are larger than 5 millimeter in diameter. These round pellets of ice are called as hail or hailstones. So children, hail is a form of solid precipitation. It consists of round pellets of ice which are larger than 5 millimeters in diameter. Is it clear children? Now let's see how hail is formed. See children, hail forms only in the cumulonimbus clouds during thunderstorms. A hailstone starts as an ice pellet inside a cold region of cloud. See children, actually hailstones are formed by layers of water attaching and freezing in a large cloud. Now what happens here is that during strong updrafts, that is during storms, what happens is that a frozen droplet begins to fall from the cloud but is pushed back into the cloud by a strong updraft of wind. So when the hailstone is lifted up, it hits the liquid water droplets. Those liquid water droplets freeze into hailstones, adding another layer to it. Thus the hailstones become heavier and heavier. This process takes place many times. Once it becomes very heavy and is no longer able to remain in the cloud, it falls to the earth as hail. So children, hail is formed when drops of water freeze together in cold upper regions of cumulonimbus clouds. So far, did you understand children? Good. The next type of precipitation is snow. Do you like snow children? Yes, you all like snow, though we do not see it in the regions where we live. Okay, now what is snow? Children, snow is a type of frozen precipitation which falls down to the earth in the form of six-sided ice crystals. These ice crystals stick to each other while falling down and take the form of snowflakes. So children, snow is a type of frozen precipitation which falls down to the earth in the form of six-sided ice crystals. Is it clear children? Now let's see how snow is formed. See children, often water vapor in a cloud is converted directly into snow pieces due to lowering of temperature. That is below freezing point. That is below 0 degrees Celsius. So temperature below freezing point is one important condition for the formation of snow. See children, snow appears as a powdery mass of ice, and this powdery mass of ice is known as snowfall. Children, snowfall is common in the polar and high mountainous regions. So children, temperature below freezing point is one important condition for the formation of snow. Is it clear children? So children, the various forms of precipitation are rain, sleet, freezing rain, hail and snow. So far did you understand children? Good. Next, let's learn about infiltration. Children, infiltration is the next component in the hydrologic cycle. So what is infiltration? See children, infiltration is the process by which water on the ground surface enters the soil. So water entering the soil at the surface of the ground is termed as infiltration. Children, infiltration allows the soil to temporarily store water, making it available for plant use and organisms in the soil. So children, infiltration is the process by which water on the ground surface enters the soil. Is it clear children? Children, what happens during infiltration is that rainwater soaks into the ground through the soil and underlying layers. Some of this water ultimately returns to the surface in the form of springs or low spots downhill, and some of the water remains underground and is called groundwater. So children, infiltration takes place on the surface of the soil. Is it clear? Children, the rate of infiltration is influenced by certain physical characteristics like soil, vegetative cover, moisture content of the soil, soil temperature and rainfall intensity. Now children, soils which have smaller pore sizes such as clay have lower infiltration capacity than the soils which have large pores such as sand. Similarly, in soils that are saturated, that is, which are already having the maximum moisture content, there cannot be any infiltration in those types of soil. Is it clear children? Okay. In the same way, the vegetative cover also influences the rate of infiltration. See children, in areas where there are a lot of plants, the roots go deep into the soil and create cracks and fissures in the soil. So naturally, the rate of infiltration is more where there is a more vegetative cover than in lands where there is no vegetative cover. Children, even the soil temperature affects the rate of infiltration. If the soil is warmer, then the rate of infiltration is more. And if it is less, then the rate of infiltration is less. Children, as I already told you, the rainfall intensity is one major factor which affects infiltration. See children, if rainfall is heavy, the rate of infiltration is more. And if rainfall is less, the rate of infiltration is less. Is it clear children? So children, infiltration is the process by which water on the ground surface enters the soil. It takes place on the surface of the soil. So children, did you understand about infiltration? Good. Next, let's learn about percolation. Children, the terms infiltration and percolation are often used interchangeably. Okay, now let's see what is percolation. See children, percolation is the downward movement of the infiltrated water right through the soil and rock layers. So during percolation, the water moves deeper into the layers of the soil and rocks. Is it clear children? Children, while studying about infiltration and percolation, you must understand the difference between the two terms. Children, infiltration occurs near the surface of the soil and delivers water from the surface into the soil and plant root zones, whereas percolation moves the infiltrated water through the soil profile and rock layers, which leads to the formation of groundwater or become a part of the subsurface runoff process. So children, the percolation process represents the flow of water from unsaturated zone to the saturated zone. Is it clear children? So children, did you understand about percolation clearly? Good. Next, let's learn about runoff, which is the next component in the hydrologic cycle. Now, what is runoff? Children, runoff is nothing more than water running off the land surface. See children, here I would like to give you an example. When you wash your car, the water with which you wash runs off, isn't it? In the same way, rainwater runs off downhill, that is on the surface of the land, and this takes place due to gravitational pull. So in short, we can say runoff is the water that is pulled by gravity across the land's surface. Children, the runoff water replenishes. Replenishes means it fills up again. So the runoff water fills up again the groundwater and surface water as it percolates into an aquifer. Now what do we mean by aquifer here? Aquifer is an underground layer of water bearing rock. So during runoff, this aquifer is filled up again with rainwater. Is it clear children? Children, after refilling the underground water bearing rock, the runoff water moves into rivers, streams and watershed. So far did you understand children? Good. Now let's see from where does this runoff water come. Children, runoff water is a part of precipitation that includes unabsorbed water from rain, snowmelt, irrigation and other sources, which also comprise a significant, that is an important element in the water cycle. So children, runoff water comes from unabsorbed water from rain, snowmelt, irrigation and other sources. Children, runoff water also takes place when water gets drained from a watershed into any stream, river, lake, etc. Is it clear? Children, on the earth, we can notice many types of landforms such as canyons, gorges, etc. Now, what are canyons and gorges? They are all deep valleys. So, children, these runoffs are the cause of such landforms. So, children, runoff is also a major contributor to the erosion which carves out canyons, gorges and other related landforms. Is it clear? Now, let's see the factors which affect the rate of runoff. Children, the rate of runoff depends on the amount of rainfall, porosity of soil, vegetation and slope. Children, if the intensity of the rainfall is more than the infiltration capacity, then the rate of runoff is more. If the slope is steep, then the rate of runoff is more. If the soil is less porous, then the rate of runoff is more. And if the vegetation cover is more, then the rate of runoff is less. So children, the factors which affect the rate of runoff are the amount of rainfall, porosity of soil, vegetation and slope. Children, during a runoff, only about 35% of precipitation ends up in the sea or ocean, and the other 65% is absorbed into the soil. Is it clear, children? So far, did you understand? Good. Okay, now let's see the different types of runoff. Children, based on the time interval between the instance of rainfall and generation of runoff, the runoff may be classified into three types. The first one is surface runoff. Children, surface runoff is that portion of rainfall which enters the stream immediately after the rainfall. Children, this occurs when the rainfall is longer, heavier, and exceeds the rate of infiltration. Is it clear? Children, in this condition, what happens is that the excess water makes a head over the ground surface, and this tends to move from one place to another place following the land gradient. Now, what do we mean by land gradient? Land gradient means the slope of the land or the inclination of the land, and this is known as overland flow. Children, in simple terms, we can say that the runoff water that occurs on the surface before reaching a channel is called as overland flow. So now, when the overland flow joins the stream, channels or oceans, it is termed as surface runoff or surface flow. So the runoff that occurs on the surface of the land and then joins the ocean, seas and other water bodies is called as surface runoff. Is it clear, children? The second type of runoff is called as subsurface runoff. Children, here before understanding subsurface runoff, you must first understand what is water table. Children, the level of groundwater is called water table. Is it clear? So children, subsurface runoff takes place beneath the earth's surface. So what happens here is that the water that has entered the subsoil moves laterally without joining the water table and then joins the streams, rivers and oceans. Children, the subsurface runoff is usually called as interflow. So children, in subsurface runoff, the water that has entered the subsoil moves laterally without joining the water table and joins the streams, rivers, oceans and other water bodies. Is it clear, children? The next type of runoff is base flow. Children, during percolation, the water moves underground, that is to the groundwater zone. Because of this, the groundwater zone gets saturated, that is, it gets the maximum moisture content. Now, from this saturated zone, the underground water moves to a water channel, that is to the rivers, lakes and other water bodies. So children, base flow is a flow of underground water from a saturated groundwater zone to a water channel. Children, base flow usually appears as a downstream location. See children, here the water channel, that is the rivers, lakes and other water bodies are at a lower level than the groundwater table. Only then the base flow will take place. That is the flow of water from the groundwater zone to the water channel. Children, one important advantage of the base flow is that during dry periods and when there is no precipitation, that is rainfall, the groundwater provides water to the streams. So base flow is the flow of underground water from a saturated groundwater zone to a water channel. Is it clear, children? So children, the three types of runoff are surface runoff, subsurface runoff and base flow. So far, did you understand, children? Good. Next, let's see some units of the measurement pertaining to hydrology. Children, evaporation or interception is measured in inches or centimeter. Next, Infiltration is measured in inches or centimeter per hour. Next, precipitation is measured in inches or millimeter or centimeter. Next, runoff is measured in inches or millimeter or centimeter. Next, runoff rate is measured in cubic feet per second. Next, runoff volume is measured in acre feet or cubic feet. Next, storage is measured in cubic feet or acre feet. Is it clear, children? Children, I hope you understood this lesson clearly. Go through the video again and learn from it. Keep reading, keep learning, keep safe until we meet in the next session. Thank you.